Alright, today we're going to talk about composition of functions. First we're going to review. So we have f of x equals 3x minus 4, and we want to find f of x minus 6. So remember, here is our input. We are inputting this for anywhere we see an x. So we see right here, there's an x here. So we have f of x minus 6 equals 3 times x minus 6 minus 4. Distribute the 3x minus 18 minus 4, and we have 3x minus 22. Okay, so now let's look at composition of functions. It'll be written like this sometimes, and what this means is f of g of x. So what it actually means is f follows g of x. Follows g of x, right? So we're going to work backwards. Right to left, not left to right. So it says f follows g of x. We're going to work right to left. Right to left. And we're going to work backwards. So from g of x back to f of x. And I mentioned down here there's another notation. It could also be written as f of g of x. So it could be written either way. Alright, let's look at our first example. So we have given f of x equals x minus 6 and g of x equals 3x plus 8. We have find f of g of x. Remember, we can see it as this notation or the other notation. So what this means is find f of g of x. So anywhere we see an x in our f of x function, we're replacing it with g of x. That's what this means. So let's put this to the test. So we have f of 3x plus 8 equals, now remember we're placing 3x plus 8 anywhere there's an x because it's our input now. We have 3x plus 8 minus 6, and that equals 3x minus plus 2. It's as simple as that. That's how you find f of g of x. Alright, now notice, switched it up. Now it's g of f of x. So what are we looking for? We're looking for g of f of x, which is x minus 6. And that equals 3. So we're plugging in our input here for everywhere there's an x here, times x minus 6 plus 8. So we get 3x minus 18 plus 8, and we get 3x minus 10. So notice that the two answers are not the same. So it's not commutative. So we have 3x plus 2 here, and we have 3x minus 10 here. So we can see that order matters. You can't just do it in any order you want, because then you'll end up with the wrong answer. So when we did f of g of x, we got 3x plus 2, but when we did g of f of x, we got 3x minus 10. So order matters. Just remember that. Work right to left, and that's how we'll find the composition. So just remember, compositions are not commutative. That's a T. Okay. And once we find f of g of x and g of f of x, the compositions that we get so 3x plus 2 and 3x minus 10, they're now our rules, so now we can take the composition of an actual number. Okay, so now when we're looking at f of g of 3, we have a number, so we're looking for, the first thing we're doing is working right to left, so we're looking for g of 3. So if you do g of 3 equals 12 minus 3 squared, that equals 12 minus 9, and that equals 3. So now we have an answer here, so we plugged g of 3 into g of x, and now we're taking that answer we get and plugging into f of x. So we get, let's move this down. So now we're looking for f of 3. And it's not always going to be the same number, so see, it's g of 3 and f of 3. You might get a different number, but we'll see that in the next example. So f of 3, our function is x minus 3, so we're plugging in 3, so it's 3 minus 3, and that equals 0. So we have f, let me erase that real quick, f of g of 3 equals 0. Alright, now that you're pros at this, we have g of f of 3. So we're finding f of 3 first, which we found in the last video, the last question. So we have 3 minus 3 equals 0. So now we're finding g of 0, which equals 12, plugging in our answer, 0 squared, and that equals 12. So we get g of f of 3 equals 12. It's as simple as that. You find the first answer here. So we found f of 3, and then we plug that answer into g. So we had f of 3 equals 0. Now we're taking this answer and plugging it in as our input here for g of 0. Alright, have a good day. We'll see you tomorrow in class.